Hi, Haru. We are going to solve the related rates problem that you posted about how the area of an equilateral triangle is changing as the sides are changing. So if you have a moment, pause the video and please write down the steps for the general steps of how to solve related rates problems in your notebook. So number one, we're going to draw a picture and label and identify your variables. Number two, write an equation for what you're supposed to find. 3, summarize all the information that you're given. 4, take the derivative of the equation from step 2, usually implicitly with respect to time. And 5, we're going to solve the equation by substituting your given values, the ones that we identified in step 3. Your problem that you posted is broken up in such a way that it actually asks you to do number 1 and number 2 as part of part A. And then what you're going to be doing for part B is the rest of the steps. So I really appreciate that you always kind of identify what part you're having trouble with and what part you were able to find. So this first two steps you said you were able to do, so I'm not going to spend too long on that. But hopefully you did it by kind of drawing a picture, right? So we have an equilateral triangle, which means that, of course, every side is the same length. And so that's x, x, and x. And the area of the triangle is, of course, A. Now, to find the relationship, right, state this relationship between A and X, that's what you're supposed to do in part A. Hopefully you kind of saw that this was a 30-60 triangle, right? You know that the height of the um, triangle, so to speak, is root 3 over 2x, and use that to write your equation. So I'm not going to go over this part because you did a great job. Area does equal root 3 over 4x squared. You'll notice I've put the kind of coefficient part in front of the variables. I think it makes it a little bit easier to take the derivative when we get to that part. So this is a part where I think you were mentioning you might have a little bit of a problem with. So step 3 is what we're going to be doing is to summarize the information that we're given. Now, these two statements are from different parts of the problem. The side length of the triangle is increasing at 3 centimeters per minute. That was given to you in the kind of actual main part of the problem. And what that basically means is that you have dx over dt equals 3 centimeters per minute. Anytime you see the word per, or you see things like increasing, sometimes you might see the word rate. What that means is you're going to have a something over dt as the expression you're looking for. So we have dx over dt equals 3 centimeters per minute. Then in part B, it specifically tells you at what rate is the area increasing when the side length is 15. Now, the question and kind of information they're giving you is put together in that. So we're going to break it apart. When the side length is 15, that's information that they're giving you. And basically what that just tells you is x equals 15 at that point. Now, at what rate is the area increasing? Question mark. That's the question we want to find. So what we really want to find is dA over dt. Now, and you'll notice that has that key word I mentioned earlier, which is rate, right? And we also see the word increasing. So that tells you you're going to get a something over dt, right? Now, in this case, we don't get that. That's what we have to find. Oops, sorry. So step 4, in order to find that, what we're going to do is to take the derivative of the equation from step 2. So this is what you found in part A. A equals root 3 over 4x squared. And what we're going to do is to take the derivative of that with respect to time. So A equals root 3 over 4x squared. Again, root 3 over 4 is just the entire coefficient. So we're going to be using the chain rule to take the derivative. So dA over dt equals root 3 over 2 times x times dx over dt. Pretty close to the end now. For our last step, what we're going to do is we're going to solve the equation by substituting all the information that we know. So I've kind of re-summarized that for you. So here's our equation, and here's our given info. Very sparse. We just have dx over dt, and we know that x equals 15 centimeters. But that's all we need to know. So anytime we see x and dx over dt, we're going to substitute these values. So we have root 3 over 2 times 15 times 3, and we get 45 times root 3 over 2. And so what this means is that the area of the triangle is changing at 45 root 3 over 2 centimeters squared per minute. Just a quick note, again, because this rate is positive, that tells you that it is increasing. If it was negative, that would mean that the area was decreasing. Also, notice that they do tell you what the units that they want for the answer, but you should also be able to figure it out because we know that area is always like square something, and units here are centimeters, so it's going to be square centimeters. And then changing at is another, it's not a very straight line, but that's another key word you can look at, that's referring to rate or time. And so, of course, since our units right now have been everything per minute, so that tells you that that's going to be per minute. So hopefully that was helpful. Feel free to reach out if you have any more questions.